Well, welcome back, geometry students. We are going to begin lesson 4 in your textbook and finally talking about some angles. This is going to be a very big topic for you for the rest of the year, so we want to make sure that we understand what angles are and how to measure them and compare them. So first of all, let's talk about the concept of an angle and what it is and how it's formed. And from our definition, an angle is formed by two rays. Okay, and we have a picture over here, two rays, and those two rays share the same endpoint. Okay, they have the same endpoint. A over here is the endpoint. The rays are the sides of the angle, and the endpoint is called the vertex of the angle. So the way that we name an angle is using this little symbol right here, angle, and then a capital letter, and that capital letter is always the vertex of the angle. So if we're labeling it with just the vertex, that's one letter. We can also label angles using all three letters, but the vertex is always in the middle. Okay, so we could label this as angle BAC or angle CAB. It means the same thing. We can also label an angle if it's got a number or a notation in the middle there. Sometimes you'll see the Greek letter alpha. I don't know if you know what that looks like, so I'll write that in here. Sometimes you'll see alpha. It kind of looks like that. So in this case we have the number 1, so we could also call it angle 1. And this just reiterates what I said, that the vertex must go in the middle when you're using the letters. And then there's an interior of the angle and the exterior of the angle. And the interior is all the stuff on the inside. The exterior is all the points on the outside. And anything that's on the angle is not in the interior or the exterior. All right, naming angles. What are two other names for angle 1? How could we name angle 1 inside here? Well, we could label it JMK, okay, JMK or KMJ. Those are two other names for angle 1. Why don't you pause the video and try this one? What are two other names for KML, angle KML, and would it be correct to name any of the angles angle M? Pause the video and I'll show you the answers when you get back. Well, two other names for angle KML are LMK, okay, remember you have to keep that vertex in the middle, or angle 2. Part B, is it correct to name any of the angles M? No, because that's arbitrary. Whenever there's more than one angle with that vertex, you have to use all three letters. One way to measure the size of an angle is in degrees, okay, and the way that we indicate the measure of an angle is to use that lowercase m. So when they want the number of degrees, you'll see it listed like this. The measure of angle A equals 62 degrees. So that's what that little m means, and usually it's italicized. So that's what that means, that they want the angle measure. That's how they will indicate that. And there are 360 degrees in a circle. So 1/360th of a circle would be 1 degree. Here we have a protractor, and most of you should have your own protractors for measuring angles. Be sure to bring those to class. It says consider ray OB and a point A on one side of OB. So suppose we have a point out here. Every ray of the form OA, where it uses the vertex of ray OB back to that point, can be paired 1-to-1 with a real number. Basically they're saying if you have a point not on the ray, you can make an angle out of it and measure it on a protractor. So let's go ahead and look at how we measure angles. In this example, we're going to measure angle COD. COD, okay? So we need to find what those coordinates are on the protractor and subtract them and take the absolute value. So for angle C right here, they're going to call that little c, and it looks like it would be, it depends on which scale you use. You just need to be consistent. You could do 45 for C, and then maybe 147 for D. Just use the same scale, or you could use down on the little scale, the inside scale, 135 here, and about 33 there, and you'll get the same answer either way. Just be consistent with which scale you're reading. Here are some different types of angles. Acute angles are bigger than 0 but less than 90. A right angle is equal to 90. An obtuse angle is bigger than 90 but less than 180. And a straight angle is exactly 180. So let's measure and classify some angles. Here we go. First of all, we're going to use angle JKL. And angle JKL, let's see, JKL is that one, yep. So that one's in green. That one turns out to be 55 degrees. So you have 90 on this scale, and they're using the 145, the inside smaller scale, and that gives us 55. Notice if you use the outside scale, you'd have, what would it be, 35 and 90 minus 35 should still give you the 55. So that would be an acute angle. How about the measure of angle LKN? LKN, that's the one in red. And LKN works out to be 145. So they're using the inside scale again. 145 here, 0 here. So that's obtuse. And JKN, that's the blue angle. And JKN is 90 minus 0, or 90, and that's a right angle. So here's a chance for you to try to do a couple of these using these same exact letters in this protractor. Find the measure of LKH, HKN, and MKH. Go ahead and pause the video and I'll give you the answers when you come back. You should have had for angle LKH 145, for HKN 180, and for MKH 145. When angles have the same measure, we say they are congruent angles. This means that their measures are congruent, so the angles are congruent. The way that we show that angles are congruent is using this little arc inside. If you have more than one set of angles that are congruent, you're going to use two arcs. You can see that down here in problem 3. In problem 3, it says that the measure of angle GHJ is 90 degrees right here, and they want to know the measure of angle KLM. KLM. Well, by looking at the markings, we can see that these two angles are congruent to each other, and since these both have two arcs, they are congruent to each other, so the measure of angle KLM must be 90. Postulate 1.8 is the angle addition postulate, and basically it says if you have a point inside or on the interior of an angle, then you can construct a ray where the big angle is equal to the sum of the two small angles. So in other words, angle AOB plus BOC is equal to angle AOC. Here's an example of how to use the angle addition postulate to solve a problem. Suppose we know that the measure of angle RQT, this big angle, so suppose we know that that angle is 155 degrees. Now that goes all the way from here over to here. It's the big angle. We want to find the measure of the two smaller angles inside. Well, we know the sum of the two smaller ones equals the bigger one. And we have some algebraic expressions for the two smaller ones. So let's go ahead and substitute what we know. Then we can get our like terms together and solve for x. Once we know what x is, in this case it's 23, we can plug that back in for our angles, the algebraic expression for our angles, and find out what those measures are. So we find that measure angle RQS is 72 and TQS is 83. And if you add those two together, you do get the 155 that we started with. On the next page, you will find your lesson quiz. Please complete this and bring it to class tomorrow. See you next time.